First, open the calculator and then add the component oxygen by clicking Add Component and searching for oxygen. Now insert the new worksheet, and here let's enter our data for the two compressors. We start by entering the temperature in degrees C, pressure in bar, and flow rate in kilomoles per second. Then we need to calculate the enthalpy of the oxygen, kilojoules per kilomole. And then, of course, we need to calculate the power for each compressor in megawatt. And the total power for both compressors, also in megawatt. And finally, we have to deal with the efficiency, which we don't know. So we're going to enter a value. And we're going to try to figure out what is the correct value. So first, let's enter the data from the inlet to the first stage, and then the outlet. And so we're going to call this the first stage. And then we're going to enter the data for the inlet to the second stage, and then the outlet. And we're going to call this the second stage. So for the temperature, the inlet is 30 degrees C for both stages. The inlet to the first stage is 1 bar. The outlet of the first stage is the square root of the inlet times the final pressure. And we know that the final pressure is 10 bar. The flow rate is 8,000 kilomoles per hour. So I will divide by 3,600 to make it kilomoles per second. The inlet pressure to the second stage is the same as the outlet pressure of the first stage. And let's assume an efficiency, let's say 0.8, 80% efficiency. I'm going to make this bold and red because it's something that we need to calculate. So now let's calculate the temperature in the outlet of the first compressor. For that, we use the function GasCom temp, and we enter our data. The mole fraction is our component 1. As you see, it's oxygen. The inlet temperature is 30 degrees. The inlet pressure is 1 bar. The outlet pressure is 3.16, and the efficiency is 0.8. I do the same calculation for the outlet of the second stage, equals GasCom temp. Again, we have oxygen as our component. The inlet temperature is again 30 degrees. The inlet pressure is 3.16. The outlet pressure is 10 bar. And the efficiency is the same, 0.8. Click OK. And now that we've done the calculations, now we can calculate the enthalpy of oxygen, equals, it is an ideal gas, so it's HIG. And our component is oxygen. And these are the temperatures. And I'm going to drag this formula. Now I'm going to calculate the power for the first stage is equal enthalpy out minus enthalpy in times the molar flow rate divided by 1,000 to make it megawatt. Let's also calculate the molar flow rates of the outlet and the inlet to the second stage and the outlet of the second stage. They're all the same. Now I'm going to calculate the power of requirement for the second compressor, which is outlet enthalpy minus inlet enthalpy times the molar flow rate divided by 1,000. And the total power is equal to the sum of the two powers. And I'm going to format this cell. Okay. Now, from the problem statement, the outlet temperature, we know that it is 165 degrees C. That means that we need to calculate what is the correct efficiency. So the outlet temperature is 165 degrees C. So we can goal seek that. Say goal seek. We set the value to 165 by changing the efficiency. We'll click OK. And the calculated efficiency is about 85%, and the total power is about 18 megawatt.